Continuing our discussion of the problem on annihilation of a positron-electron pair, in the last part of the problem, part F, if the positron with speed v was traveling in the plus x direction, then with what speed u should we perform a Lorentz velocity transformation to bring us to the center of momentum frame where the total momentum is 0? So we have a center of momentum frame that moves with a constant speed u with respect to the lab frame, and in this reference frame the total momentum is 0. So the total momentum measured in the primed reference frame should be equal to 0. So that means if we measure the velocity of the positron in the prime reference frame, that must be equal to minus the velocity of the electron on the x-axis, because the motion is on the x-axis. All right. Now, if we perform a transformation between these reference frames using the Galilean transformation, we know that the position of a particle at point P is r according to the lab reference frame, r prime according to the s prime reference frame, and the two reference frames' origins move by a distance ut in a time interval t. So we can write r is equal to r prime plus ut. That means because this motion is on the x-axis, x is equal to x prime plus ut for the x components. And here our particle is moving on the x-axis, so there is no other component. And in the Galilean transformation, t prime is equal to t. Both reference frames measure the same time. And if we take a time derivative of this equation, dr dt is v, velocity measured in the lab reference frame, is the velocity measured in the primed reference frame plus u, and this is all happening on the x-axis. So we have v is equal to v prime plus u. And what we have just done here is Galilean transformation between the lab reference frame and the center of momentum reference frame. Okay, and if I look at the Lorentz transformation version of this, you know that instead of x is equal to x prime plus ut, we have x is equal to x prime plus u t prime multiplied with the relativistic correction factor gamma, and the time, instead of being equal to t prime, t is equal to t prime plus x prime times u, x prime u divided by c square multiplied with relativistic correction factor gamma. And if we take the time derivative, we have dx dt so let's do it here. Dx dt is equal to basically v, the velocity measured in the unprimed reference frame, is equal to v prime plus u divided by 1 plus v prime u over c squared. So we're looking at dx, which is dx prime plus u dt prime times gamma, and then we take it into dt prime parentheses, we get dx prime divided by dt prime, which gives us v prime, and that the second term gives us u, and we have a factor of gamma here, and because we're dividing this by the dt equation, gammas will cancel. So here we take this into dt prime parenthesis, we will get 1. And for dx prime dt prime, we have v prime, so v prime u over c squared. So that's the correct transformation from the s prime reference frame to s reference frame. If I do the transformation from the s reference frame to the primed reference frame, this is going to be modified to be v prime is equal to v minus u divided by 1 minus vu over c squared. So these plus signs becomes minus, and this part is primed version, this part is the unprimed version. So that's the transformation from S reference frame to S prime reference frame. So we're talking about two transformations here. So on the at the beginning, I have performed Lorentz transformation between the two reference frames, and here I have Lorentz velocity transformation between the two reference frames. Okay, so having recalled these results, let's see the application here. The positron in the lab reference frame is moving with a velocity v, and in the primed reference frame, going from S frame to S prime reference frame, it will be moving with this v minus u over 1 minus uv over c squared, performing the Lorentz transformation. The electron was at rest in the lab reference frame. Now it should be basically equal to minus u. So this is going to be applying the Lorentz transformation here, 0 minus u divided by 1. It's going to be equal to minus u in the primed reference frame. So I applied the Lorentz transformation to the electron velocity. For the primed reference frame, its velocity is minus u. Okay, now we know that in the center of mass, center of momentum reference frame, the primed velocity for the positron must be equal to minus the primed velocity of the electron. So we find that v minus u divided by 1 minus uv over c squared must be equal to minus the velocity of the electron. The velocity of the electron is minus u in the primed reference frame, so it's going to be equal to plus u. All right. So this tells us that we have multiplying this with u, u minus v u squared over c squared is equal to v minus u, or we can write this as u c squared minus v u squared is equal to v c squared minus u c squared. All right, so let's rewrite this here. V u squared minus 2u c squared plus v c squared is equal to 0, or this can be written as u squared minus 2c squared u divided by v plus c squared is equal to 0. So I'm taking this into v parentheses. So what is the solution to this equation, quadratic equation? Now the solutions will be u is equal to minus b, which is minus of this, so it's 2c squared over v, minus b divided by 2a, so it's divided by 2, and then we have plus or minus square root b squared 4c to the fourth power over v squared minus 4ac 4c squared times 1, so this is going to be minus 4c squared inside the square root over 2a, so that means we have a 1 over 2 here. Okay, and so for this one we're going to take the positive root to answer this question. So that means u is equal to c squared divided by v plus, now you can see that there's 4 here and 1 over 2 here. 4 comes out of the square root as 2, so that will disappear. I will have c squared coming out of this as c, so plus c squared over v squared minus 1 square root. And now I recall that 1 over square root 1 minus v squared over c squared is equal to gamma. That means gamma squared minus gamma squared v squared over c squared is equal to 1 if I take the square of both sides. And this is going to give me gamma squared minus 1, so I take this to the left hand side and this to the right hand side, so divided by gamma squared is equal to v squared over c squared. So this is going to give me c divided by v is equal to gamma divided by square root of gamma squared minus 1. Okay, so here I have c squared over v squared. So u is equal to c squared over v plus c. C squared over v squared is gamma squared over gamma squared minus 1. And then I have minus 1 inside the square root. All right, and that means u is equal to c squared over v plus c times gamma squared minus gamma squared plus 1 divided by gamma squared minus 1 square root. And this is going to be c squared over v. Now you can see that these gamma squares will cancel, plus c divided by square root gamma squared minus 1. All right, So this is C times C over V, which is C times gamma over square root gamma square minus 1. And here I have C over square root gamma square minus 1. And this is going to give me in C parentheses gamma plus 1 divided by gamma plus 1 gamma minus 1 square root. And that means my U is equal to, because this is square root of gamma plus 1 parentheses squared, they will cancel out. So I will have C times gamma plus 1 divided by gamma minus 1 square root. So in the Lorentz transformation, that's the U I need in order to transfer to the center of momentum reference frame. So let's see what we did here. We were asked to find the speed U that we need to perform the Lorentz velocity transformation with to bring us to the center of momentum reference frame where the total momentum is 0 if the positron was traveling with speed v in the plus x direction and the electron is at rest to start with. So doing the transformation between two reference frames, that one is moving with a relative speed u with respect to the other on the x-axis, we have remembered the Galilean transformation, which tells us the velocity v reported by the S reference frame is v prime plus u, and the position is r prime plus ut, and time is absolute. Going to the Lorentz transformation, we take this equation, x prime plus ut, t becomes t prime and multiplied by gamma. For the time transformation, it becomes t plus x prime u over c squared times gamma. If we take the time derivative dx dt and take this into dt prime parentheses, we find the proper Lorentz velocity transformation. V equals v prime plus u over 1 plus v prime u over c squared. And for the transformation from S to S prime reference frame, this becomes v prime equals v minus u over 1 minus vu over c squared. In the S reference frame, Vp is equal to V, Ve is equal to 0. In the S prime reference frame, we use this transformation, V minus U over 1 minus UV over C squared. For the velocity of the electron, V it was 0, so 0 minus U over 1, it is minus U. In the center of momentum reference frame, Vp prime is minus Ve prime, so it's U. So we use this equation to solve for U, and after doing some algebra, we reach this final answer. U is equal to C square root of gamma plus 1 over gamma minus 1.